Um, how many of you recognize this image? Okay, what is it? No. It's not Docker. Huh? No, it's not DigitalOcean. Oh, this is, I realize this is a very old Twitter, right? This is called the fail whale, okay? So, Twitter was notorious when it started. It was really notorious, it'll just crash. And whenever Twitter crashed, if you go to twitter.com, this was the image you would see. It was called the fail whale. And it was fairly well known. A lot of people have seen it in the initial days of Twitter. And it was practically a joke, fail whale. So it's become something that you talk about. And so let's look at Twitter as somebody and how they started, what it was, because unless we understand why choosing a stack is so important, we will not spend enough time. So this is actually, oh, by the way, do you know who started Twitter? Jack Dorsey, right? So this is actually his notebook and this is his first sketch before he actually started to create Twitter. So Twitter was a side project for him. It was not something which he was doing as a student. Hey, let's do something, guys. And it was not started as a serious project. It was just something that a bunch of guys. The company he worked for was using Ruby on Rails. So, hey, let's write it in Ruby on Rails. Yeah, let's write it in Ruby on Rails. And the initial Twitter version was written on Ruby on Rails. And it caused a real problem. When Twitter was written, how many of you know that Twitter actually worked with SMS? Has anybody actually sent and received SMS from Twitter? Nobody. When Twitter started, it started as a way that you could send a status update from your SMS. They had a special code and it would distribute to all people who were watching you. Okay? And everybody would receive the message as an SMS on their phone. Okay? This was how it was initially designed. And there was a twitter.com which is basically look like this. You would just do your status update from the website instead of sending an SMS. How many of you have actually visited twitter.com and posted a message from twitter.com? 1, 2, 3. So some people have actually gone to twitter.com. Nowadays, everybody has some Twitter client and you're posting using your Twitter client and the Twitter feed is coming on your client, right? You're not going to twitter.com website. That caused a huge problem. The fail whale was because they had designed it saying that, listen, people will send SMS or they'll come to our website and post an update. And Ruby on Rails is good for that kind of stuff. Ruby on Rails is a good choice. And if you're sending SMS, anyway your provider is queuing the messages for you. You don't have to worry about it, right? If you have an API and you're pulling it from your provider, the queue is maintained by your provider. You don't have to worry about scaling, nothing. They also incidentally provided an API so that you could write a Twitter client. People could write Twitter client. But within 6 months, there were hundreds of Twitter clients, and the only way people interacted with Twitter was through dedicated Twitter clients. So the 10x of the traffic from Twitter came through the API, not through SMS, not through their website. And that was the main reason for it collapsing so often initially. This was the main reason it kept collapsing so often initially. And they realized it was a problem, then they started re-architecting it, so they put up a Scala, they started rewriting the API using Scala and things like that, and gradually over time, the fail whale disappeared. Right? So there was another app which was basically meant for sharing status, and this is what the founder had on his whiteboard. So can anybody guess what is this status sharing app? WhatsApp. Okay, very good. So who said Twitter? That deserves a chocolate. Who said? You chose. Said it was Twitter, right? You said WhatsApp first, right? So this is what Brian Acton. WhatsApp also started as a status sharing app, but it gradually became a messaging app over time. Strangely, WhatsApp has never crashed. I mean, you never hear of WhatsApp having problems. Has anybody had problems with WhatsApp? It's just something that works, right? You have? That's nice. What happened?
31st December it was unreal.
31st December? Oh, okay.
In India.
In India, right? So I think we've gone beyond their they've moved to Facebook, so that may be part of the problem. Right? They are no longer WhatsApp as WhatsApp. This is started as a sharing, and WhatsApp became the messaging king. So what platform? We said that Ruby on Rails was what was used to write Twitter. Erlang. Okay, very good. Erlang. So what is Erlang? What's Erlang? Huh? Yeah? So Erlang stands for, it's actually started by Ericsson, and it's the language they use on their telephone switches, right? So when you have a telephone switch which is routing all the calls and all the SMSs that are coming and things like that, it's very lightweight. It spawns off threads with absolutely effortlessly spawns off threads, and everything runs as a thread, and you do communication which is totally, what's the word? Anyway, I'm missing the word. So the strange thing is Jack Dorsey was a hardcore techie guy. Jan Koum was the guy who founder. Jan Koum and Brian Acton were the founders. They were really not techie guys. Jan Koum was the guy who really started it off. He was not a techie guy. He was a product manager type of person, right? He was not a hardcore techie guy. But he and the first coder, he went to rent a coder and hired a coder, and so that guy was working as from rent a coder. So he used to give him assignments. That guy used to work. They started with something called eJabber, which was back then XMPP, or anyway, that was very long back. So they started with that, and who did it? Some rent-a-coder guy did it. And this out-and-out techie guy wrote this Twitter, and it kept crashing. And this completely non-techie guy hired somebody from rent-a-coder. He has this terrific reputation. Why? How? Isn't it strange? I mean, I know you may not, not many of you may have heard this history of WhatsApp and Twitter. But when you think of it, it seems very strange, doesn't it? And so let's understand how and why it's different. When Jan Koum and Brian Acton started WhatsApp, they were very clear. We want to be on every smartphone on the planet. That was their stated goal. That WhatsApp has to be on every smartphone on the planet. And so, they were always calculating on that basis. What are these numbers? At that time, 2 billion. They were saying that there are roughly 2 billion smartphones when they were doing these calculations. And they used to test how many simultaneous connections can one server take. Okay? And at that point in time, 200,000 simultaneous connections was what a server running Erlang could support. So they said, okay, we need 10,000 servers. Wow, that's a lot of servers. So they hired, I mean, you should see some of his, I forget his name, he has given some talks on how to do scaling of software. He later joined WhatsApp, right? Very early days still, right? He would go and go deep into Beam. Beam is the equivalent of JVM for WhatsApp. Right? It's the equivalent of the JVM is called Beam. So he would trace his code into Beam, into the OS, into the Linux. I think they were using Debian. So he used to go deep in, he would modify Beam and submit the patch back. He'd modify the OS, and Jan Koum just told him, just get me a version of Beam and OS which can support 2 million connections, not 200,000 connections. Then I only need 1,000 servers, right? Not 10,000 servers. So the main reason for WhatsApp having that kind of stability, right? That kind of stability was, there was a vision. They knew this is what we want to do. We need to scale to this level. And they used to be constantly measuring it. They used to constantly measure to find how many messages are in the queue. All the time they'll be measuring how long is the queue of messages which I have to deliver. If it went about a particular size, they start getting worried. They start looking at it, doing it at more servers, is there more tweaking that I can do? And that was something that they were constantly doing. And even today, right? Even today, WhatsApp doesn't give you an API. You can't, can you write another app which sends messages? No, WhatsApp is WhatsApp. So they had this focus, and it's truly, I mean, if you read WhatsApp history, right, it is truly amazing because they had this focus. They said no APIs. Nobody can use, I don't want to be a platform. I don't want other people to send messages to me. I want my application running on every phone, smartphone on the planet. That has been their goal, and I think WhatsApp is, how many people don't have WhatsApp on their smartphone? Wow. I'll tell Jan Koum about you. Oh, that's because you don't have a smartphone. If you have a smartphone, you're likely to be having WhatsApp. If you don't have a smartphone, yeah, then you may not have WhatsApp. So let's look at the contrast. At this was, I think, just before WhatsApp got taken over by Facebook. The first number is how many people are working, comparing Twitter and WhatsApp. On the left is Twitter. Twitter had 3,500 employees. WhatsApp had 55, including support. Not developer, not 55 developers. The entire WhatsApp team consisted of 55 people. Initial failures, consistently robust, kept getting majorly re-architected. WhatsApp was always about incrementally enhanced. So I'm just comparing these two for us to think about. So first of all, this is what I'm discussing is no use if you're working in a large organization and you have no choice about what stack to use, right? It's basically useless. If you are already committed to a stack, again this presentation may not be of much use, but if you are starting and you're creating an app, maybe this presentation will help. And if you are in those other positions, it may help you look at the problem differently. So, what is the solution? How can you scale like this? In my way of thinking, these are the two critical things. When you are thinking of scaling software, these are the two critical things that matter. What is the software stack you're using and how modularly are you writing your code? Anybody say that there is something else which is equally critical, more critical? Hardware sizing, yeah, but as we saw in what Jan Koum was doing, hardware sizing is something that you attack with the software stack. So, when I discuss with people, yeah, this looks to be the problem. This looks to be the decision we have to take, which we have to take, right? Now comes the hard part. I'll take a decision about my stack. I have to decide modularity, what does it mean, how do I achieve it? And we hit what is known as the salt curve problem. So, this is known as the salt curve, or it's also called the Laffer curve. So, if you have too little salt, it doesn't taste good. If you have too much salt, it doesn't taste good. It's the same thing. If you have to take a decision on your software stack, if you spend too little time thinking about it, you're in trouble. It's like, you know what Dorsey did. Hey, we are doing, hey, let's do it in Ruby on Rails. What does it matter? We'll figure it out as we go along. Or you could have people who spend what is the stack, so they will go and think about it, do some R&D for 2 years, and they have not yet started their app. So you could be spending too little time, or you could be spending too much time. What you need to be able to do is spend the right amount of time. So how do you find that out? I have to take a decision. How do I decide I'm spending the right amount of time? It's not too little, it's not too much. That's the problem. Once you understand the problem, we'll see how things work out. So, how do you stay on the salt spot? This is a very old engineering answer. If you're a mechanical engineer, you learned about it in college. It's called a set point. If it goes too low, push it back. If it goes too high, push it back. So you have a set point which decides it should stay here. So basically, to take a decision, we need some way to measure, am I spending too much time? Am I spending too little time when I take a decision? This is a general problem I'm discussing, right? It's not necessarily just applicable to software stack. We are discussing it in the context of software stack. But anytime when you have to take a decision, you can, I spend months on taking the decision. Or you could say, I'll just go with it, man. I don't care. The best way is to have a set point for decisions. And the set point for decisions is actually decide on the exit. Saying that I'll stop thinking about it after I have reached this, after I have got this particular information. Before I start, I think of why am I doing this, what is the best way to do it, and I say I will do enough research until I have this piece of information. Once I have this piece of information, I'm done. I'm not going to spend too much, I'm not going to spend more time, and until I find that piece of information which meets my exit criteria, I'm going to keep researching. So, whenever you're taking a trip, right. How is baseline different from exit criteria? I mean, are you using a different word for the same thing, or do you mean to say that
minimum minimum number of users?
right? Yeah. So that is the target. I mean, I'm setting a goal. I want to write a software which scales to this extent. How do I decide the software stack? How do I decide what do I do? Am I going to use the newest Golang, or am I going to go old-fashioned C? Am I going to use Rust? Am I going to use Node.js? I have so, and actually life has become very hard. In the olden days, you had C, and that's it. And if you were not a C programmer, probably had Fortran as a choice if you were doing scientific computing as a part. Now there are so many stacks, and the decision is becoming harder and harder. And the thing is, you need to take the decision that this is when I will exit. And so that's to set the base for it. Let's see, what is your exit criteria for the stack? It is a proven stack for your type of software. So when I say that, let's just look at Yancom's choice of Erlang. So they were very clear in WhatsApp. What they want to do is be on every smartphone, and they wanted to have messaging. Was there any other application which did that, and which did that robustly? Was there any successful piece of software which did that? There was no software which did that. But if you look at telephone switches, that's what they did. They did SMS. So the closest equivalent to your type, the type of software that WhatsApp is writing, is SMS. So you say, okay, there is a proven stack. Everybody who is doing SMS is using Erlang. Or there are people who are using Erlang to do this. I choose that stack. Because it's proven you cannot, whatever experiments you run at the startup phase, you can never actually do a load test to the extent which you will get when you actually scale out. You cannot run a realistic test on the basis of which you say, I think this is the right stack. It's impossible. You will not have the resources. Maybe, if you're like Google or Microsoft, okay, I don't know what stack, let me write a language. Okay, let me write Angular, let me write Dart. That's a different game, right? If you are writing an an application and you need to choose a stack, what you need to look very closely at is what is the closest equivalent software. So if you're writing something like Facebook, you look at what's Facebook using for its stack. If you're doing content delivery, you look at what is YouTube using for its stack. If you are you don't have huge amounts of data, but you expect lots and lots of people logging into your system, you see what game developers are using as their stack. Because there's not much data storage. And you need to think out of the box and think. Supposing I am writing an app, there's not much storage, but there's a lot of concurrent interaction between multiple users, which is different from WhatsApp. Right? Concurrent interaction as people are something like Slack. So you would just, Slack is a bad example because it stores a lot of data. So a game, right, you have an online MMO, RPG kind of things where a lot of people are doing concurrent interactions. So you go, hey, what is those guys using for a stack? Think out of the box, like WhatsApp, there's nobody else who's doing something like this. SMS is a close, and today, as they say, right, software eats everything. Ultimately, there is some software behind it, even though it looks like SMS is a hardware thing. There's a software behind it. There's Erlang. Let's look at Erlang then. So, spend your time trying to classify what is the type of application I'm writing. Then, look for a successful, scaled out app which is similar and say, let's go with that. Let's go with that stack. That gives you the best chance. So, let me give you a few practical examples. My friend and I, we keep creating apps, we do all kinds of things. So we were writing a web app. So what's the first thing we did? We looked at, okay, let's name 5 other web apps. So we were wondering, should we use React, should we use AngularJS, should we write it as straightforward JS, JavaScript without using this framework? What's the best way to do it? I don't know. Right? Should I go to the Angular stack? Should I go to the React stack? Should I write native JavaScript? We didn't know. So we had to take that decision. So what's the first thing we did? Okay, what are the closest web apps which, when you're choosing Angular and React, one of the factors which affect your choice is how responsive is it, how does it look, what the UX is like. So we said, okay, let's choose 5 web apps where we like the UX. So we didn't do anything else. First we decided, let's look at, hey, I like this UX, I like this UX. So we chose 5 different websites which had a UX which we liked, and we said, this is the kind of UX I like to do. We went through the source of those sites and saw that only one of them was using React. 4 of them were using plain JavaScript. So we said, and actually when we looked at it a little closer, the guys who were not using plain JavaScript, yeah, this is actually number 5 in our list of web apps that we like. So it became very clear. We'll write native.js. Then should we use TypeScript? Elm. So again we looked at demonstrations of what do we like? Hey, Prezi. Well, I don't know if you guys know Prezi. It's a presentation software. Which is online. It's competing with all these Microsoft PowerPoint-like lookalikes. It's using Elm. Hey, I really like this look, and they've done this look using Elm. Let's go with Elm. we have to learn L, we learn L. I mean, I don't want to bother about what I know now, because for sure in this industry, if you're not willing to throw away whatever you've learned and start learning all over again, you're in trouble. So we did not take the stack decision like that. We looked at, oh, this is what these guys are doing, right? So let's choose this. So that's what we did. So this is for stack, and this would have been the end of my presentation. But I said, my friend said, you must talk about something about modularity as well. So this quotation which I will read is from the first, wait. We propose instead that one begins with a list of difficult design decisions or design decisions which are likely to change. Each module is then designed to hide such a decision from the others. This is the first time ever in a white paper people talked about modularity. Before this white paper, people did not know you could write modular software. So I was going to ask who it is. There was a hand already up there. Sure. Yeah. Not able to hear.
There's no benchmark. What is it?
Yeah, I get that we should compare. We are trying to develop. We should see if there's an existing product. Compare with it. But what if it's not there?
That's where you need to get a little creative, right? For example, you will be writing a business app, but if you have to see what is the type of user interface, what is the type of storage, how much storage do you want to do, which is why I'm saying I may be writing a business app, but there is no other business app like this. The closest is games. Yeah.
There was nothing there. Someone was the first player there.
Yeah.
First to market, right?
Right.
So they must have done something extra. Because there was no benchmark. So
Right.
I'm asking your suggestions for that.
Okay. Yeah. Honestly, if you're in that kind of situation, you better have very deep pockets. That's all I can take, right? Because then you need to. This exit criteria no longer works. This exit criteria no longer works. You need to set up the exit criteria of, hey, it needs to, whatever makes it unique. No, it needs to handle this much storage, it needs to handle so many concurrent users, and you need to run, then you need to set up your exit criteria by deciding what tests I will run to meet that, because if there is no proven stack by somebody else, you have to do that testing yourself, and getting testing to that scale needs deep pockets. So coming back, two questions. Who said this? When was it said? Before this white paper was published, people did not write modular software. And this is the classical definition of modular software. Anybody? Any idea? Huh? No, that's... He's very recent. Right? So, this was this is a paper by D.L. Parnas. It was written in 1972. Okay, and this is, in my mind, the first time he defined what is modularity. I really read it all the time, because, and we just spent a few minutes discussing this. If we understand this, we decide we can do modular very easily. So for my second exit criteria for modularization is, make list of decisions with high uncertainty or which are likely to change. And make sure you're isolating them by making it a model. So it sounds a little abstract, so let me give you an app. Again, I'm writing some apps with some of my friends, so let me give you a practical example. So we had write a mobile app. We were thinking of a web app as well as a mobile app. So we were looking at what shall we do with mobile apps. We were again, first we had to choose the stack. Then we had to decide what is it that we are going to do. Are we going to write native apps? Are we going to write pure web apps where it's actually just a link on the phone, or is it some cross-platform? What cross-platform are we going to use? Yeah, this is a typical situation you are in when we have to do. So we finally decided we will go cross-platform, which is a stack decision. Now I will decide what is modular. So first, the fact that unlike for the web UI where we were very clear that we are not using any React or anything, we are going to do with main.js, and we are using Elm. We were not able, did not have that confidence. We were saying we may have to fall back to writing native apps if things don't work out. And though we looked for things which were doing some of the things which we wanted to do, we really didn't find something. We really didn't find a cross-platform app which did that completely. It did 90% of what we wanted to do, but there was some shortfall. So it stayed a high uncertainty decision. So when I look at cross-platform app and a native app, what's likely to change? What's likely to change between a cross-platform app and a native app is being able to access the capabilities of the phone in terms of the mic, the camera, and this is where cross-platform guys struggle, right? The native apps give you complete access to all the capabilities of the phone. When you're talking about a cross-platform app, one of the things which is like if we change back, this is something which is going to hit us. So when we are writing this app, we are very focused on saying that whatever area of the app which accesses native capabilities of the phone, it has to be accepted. It has to be separated. We are focused on that. We are not going to allow that to become mixed up in the rest of the code. We want to take it away as a clear module, and that decision is coming because of this. So what do I have to focus on modularizing? Let me give a counter example, right? Supposing I decided to go with a native app, that choice is made. There is no uncertainty about it. Then I have to do data storage. Today, if I have to do reasonable amount of data storage, it is SQLite. There is no other choice actually, right? If you are doing storage, database like storage on a mobile app, there is no uncertainty. If you are doing it's not likely to change. So I may say the engineering effort, because ultimately it's about cost. What is the engineering effort to write this as a separate module? I may say, listen, I'm not really going to spend my time in isolating my SQLite access. I'm not going to try to modularize it because it does not meet either of these criteria. It is only you have to be able to sit down and think, what am I not certain about? What is likely to change? And you need to spend the engineering effort to modularize that. That's what's going to help you scale. Because what will happen is, you'll be doing something, say I'm using SQLite on my, then I say, oh my god, this much data SQLite is not handling. I need Postgres, something. If you are uncertain about how much data actually the user will store with me. So initially you think, hey, I don't think we don't have to do much storage. And I'm writing a server app. It's uncertain how much data which the user will store, how many users will come in. So I'd say I would spend a lot of time modularizing and segregating the data access portion of it. Because I know this is likely to change. I have to take that decision to modularize that. So I will end with a quote. Unfortunately, I desperately looked to find who actually did this quote, but I never could find. So let me read it out. I think it is a fantastic quote. Unsuccessful people make decisions on their current situation. Successful people make decisions on where they want to be. So this fits in with our Twitter WhatsApp very strongly. Why did Twitter get written in Ruby on Rails? Twitter got written in Ruby on Rails because hey, we all know Ruby on Rails. Why did WhatsApp get written on Erlang? Because they were very clear, we need to be on every smartphone on the planet. That was what they were gunning for. So they took the decision. And so, as a generic thing, I leave you with this. And that's it. Any questions? Yeah.
So I think Ruby on Rails, right? So I just wanted to talk about that. So do you think really selecting Ruby on Rails was something which was a wrong decision, that the founders have done a mistake, or they have not been actively or properly able to use it? Because I'm in Ruby on Rails from last 6 years.
Right.
Right, and I almost go to all the conferences. No, so what I'm saying is, any platform, they have pros and cons, right? If you really don't know how to use it, I'm not saying they're not going to, but they are not able to use it to an extent that it should happen. Because when Max writes something, come on, it's a beauty. And then when it comes to people like us, right, we screw it up, like the way we want.
So I like Ruby on Rails, but I think for the application that Twitter was trying to write, Ruby on Rails may have been the wrong choice. Ruby on Rails makes, writing a database app where you have to store data and things, a lot of things, very easy. I need to create what we call a CRUD, which is create, read, update, delete kind of app. I can knock out, it allows you to knock out an app like that very, very fast. You can't do it as fast with any other platform. That is its strength. But is Ruby on Rails the right platform where you're expecting hundreds of people to be pumping in data to you through a web API, and you return a lot of concurrent connections coming in through a web API to return it? Is Ruby on Rails the right platform? That's the question, right? The question is not, I'm not saying Ruby on Rails is a platform. I'm just saying that for the type of application, they didn't think, they just, said let's do Ruby on Rails because I know Ruby on Rails. They were probably writing database-based applications, and that is what the business model was, and because they knew it, they were just doing it with that. Yeah, there he asked first, or rather he raised his hands first.
Considering the scale of Twitter now, what stack you are going for that make it was?
I still think for the application Twitter is, Erlang is still the best choice. Erlang is still the best choice. They have solved their problem by going with Scala and things like that. But I would still say Erlang would have been the right choice.
That is you giving Erlang what?
Yeah, it's see, it's trying to do something different, and it's trying to move Erlang out of the type of. It's trying to say that you can use Erlang for a different type of app, and I think there is something in that, especially because as more and more courses come in. But that's a separate discussion. We'll take it separately. Yeah. There's a question here.
Hello, Jimmy. I have a question regarding the tech stack choosing. So shouldn't we consider the cost involved? For example, you select a platform independent or multi-platform app. So you need not develop for each platform. You should, as you told, make a hybrid app. So another thing is like, in my company maybe people are still in Java. They are not doing Erlang. So considering that cost as a training cost. So what's your take on that? Should we consider cost?
So, if you have an existing skill set, and that comes down actually to this quotation, right? You're making your decision on the basis of your current situation, right? And if you're saying, and you need to think about it very clearly, and there's a cost aspect, right? You need to think about it very clearly and need to structure your app and structure your team saying that, listen, I know Erlang is good. I cannot afford hiring Erlang programmers. That's my first problem, right? I can't even find Erlang programmers, forget hiring them, right? I can't even find them. So I can't use Erlang. So what do? So either, like, what did Yankum do? He went to rent a coder and he says, hey, I want an Erlang guy who knows each other in Erlang. He found somebody and he did it, right? But he kept control. He product managed it right. So you have to think creatively. So did Yankum have a team issue or what? No, he did. He just looked at it and said, this is the best thing. So let me get two guys to rent a code. Yep. One last question. Out there, somebody. One.
Quick answer.
Right.
When we are selecting the stack, we choose it for for 10 years, 15 years. But there are a lot of technology disruptions happening nowadays, like we see the ventilation technology and AI and the similar things. So how we should select a stack which can adopt the things on a smooth way.
That's going to be a long answer. We'll discuss it separately. Yeah.
So what is the language feature of Erlang? What makes it possible?
It makes threads very, very, very lightweight, and you can write concurrent apps very easily and have concurrent, these threads communicating between them very easy. So you create a thread and it dies, and you don't have to worry about maintaining the thread. You don't have to create a thread to do nothing. Threads just, it's very low cost to do that.
How it is different from a Node.js?
Guys, can we take this during the break?
Right.
Because I know this is going to be a long discussion.
Right. Yeah. Thanks everybody.